Hi, this is a presentation for like the RAID architecture using the Reed Solomon Erasure Code. So most of the traditional RAID structures are the one that are shown in the slide. Most of them are like there is a column 0 and a column 1, and to have protection of more than 2 drive failures on any of the columns, there is a global parity, two of the global parities. So now, when there is a read, then the data is validated sectors of the disks. Most of them could be like 512, 520, 1K, 2K, 4K, and the reads are just protected by the ECC in the sector. Now, whenever there is a write, the traditional Reed Solomon, the writes happen on the whole column, and all the drives are actually involved, participating with the new data to be written, and the new local parities are also calculated for that column. So let's say there is a write on column 0, the local parities 0, 0 and 0, 1 are calculated, and the whole data is written into the column. Now, this also needs an update to the global parity. So global parity 0 and global parity 1 needs to be updated. Now, this can be done either by reading that particular area in all the drives in column 1 and then calculating the global parity and then writing it back. Or if there is just update to one of the columns, then there could be more of the incremental parity that can be written to the global parity 0 and global parity 1. Now, in case of failure of 2 drives, most of the columns can get reconstructed by using the local parities. Now, if there is 3 drive or 4 drive failures, then it has to go to the global parity 0 and global parity 1. Now, for reconstruction, it is actually required for if there are 3 or 4 drives failure, then it has to go through, it has to read column 0, column 1, and global parity. That actually involves too much of network traffic. If there is more than 4 drive failures, anyway, there is no capability of reconstruction after the 4 drives. So there is another method which is like the orthogonal Reed Solomon Erasure reconstruction. So now in this, any of the reads can be similar to the previous one, where all the data is protected by the ECC in that sector of the drive. Now, the major difference in this structure is that if there is update to one of the drives, let's say 5 and -4, then we don't have to update the whole column, like the x-axis, or the whole column on the y-axis. So these are just passed through with 512 and 520 or 1K, 2K, 4K sector sizes. Now, when there is a write to one of the drives, then there is a trick that can be done here. The trick is there has to be a read on the drive that needs to be updated. And once the read happens, we have to make sure the data is correct, which can be done by having the ECC in that sector. And once we have the old data and we have the new data. Now a delta of the drive data is calculated. Now using that delta, a new delta of the parities on the x-axis and the y-axis are calculated using Reed Solomon Erasure Encoder. Once that happens, the new data is written into the drive, and whatever delta parity is calculated, it is XORed on the x-axis parities and the y-axis parities. Now, any of the two drive failures on x-axis or y-axis can be easily reconstructed using most of the parities available on that line. But what will happen if there are 3, 4, 5 drive failures? So in that, let's consider like a 3 drive failure. In a case of 3 drive failure, let's say on the x-axis there is 3 drive failure, then the third drive can actually go on the y-axis and try to get reconstructed on the y-axis. And once it is reconstructed, it can go back to the x-axis and it can have all the 3 drives reconstructed. Now, if there are 4 drive failures or 5 drive failures, then each of the other more than 2 drives, the third drive, fourth drive, fifth drive, can go into the orthogonal axis and get themselves constructed and come back, and then the 2 drives can get reconstructed in the current axis, current dimension. So makes it very highly available and very fault tolerant system, and it can easily scale to a very large number because it can go like 2 dimension, 3 dimension, 4 dimension. And if there is any interest in having the Reed Solomon Erasure Encoder Decoder in Verilog, please contact me. Thank you.